Hey guys, welcome back to my channel. My name's Saga and I'm an aerospace graduate who's working as a software engineer now, and well, I thought maybe I need to actually utilize my degree as an aerospace graduate. So today what we're going to play is some Kerbal space program. Yes, we're going to play a game on my channel. You know what? Let's just jump straight in. So I think, a good mission for today will be trying to get a Kerman, I think that's what they call Kermans, yeah, onto the moon. So let's begin trying to make that happen. So I've not played this game in a long time, but we can attempt. Right. So first things first, gotta have my own rocket fuel, which is literally just oat milk and coffee. Okay, so here's yeah, this is a test rocket that I made basically when I was figuring out how to record a video game on here. So let's make a moon rocket. Let's Okay, so what do we need? We need a command pod, and we need some sort of parachute thing, I believe, which is here. Right, so parachute on. See, as a real aerospace engineer, I should be calculating all this stuff, but you know what? We'll just wing it, to be honest. Right, so what we need is decoupling. Yes. Does this one fit? Yeah, nice. So what we want to use is a fuel tank as well. Probably need a smallish one, like this, if we're going to go on the moon. Yeah. And then we need some engines, so... Right, so this is where you figure out how much aerospace engineering actually helps you in Kerbal Space Program. His secret, not much, but that's only between us two. So, right, let's launch this thing. So I remember T is for stabilizing the rocket, Z is max thrust. This is insane. How I have not played this game in years, still remember half the controls. Okay, so what do we want to do? We want to... Well, I guess we need to figure out where's the moon, because this is our target. It says target, right. But what we want to do is... I guess we can figure it out as we go along. I think that's how everyone does it in the space industry, right? Okay, so let's go for launch. Looks very sturdy for now. Pretty sick rocket, if I'm honest. See, if only I had monies like Jeff Bezos, could have already taken humans to the moon. Right, let's have a look inside. Pretty sweet stuff. I like how they have it in meters per second, because that's literally how you measure speed in engineering. You don't mess around with like miles an hour or whatever. It's literally everything is just meters per second. Right, probably should focus on the target now, I think. Yeah, I think that's good. It's actually funny. So I don't know if people have watched SpaceX launches or so on. So they always have a call out called max Q, and Q is referring to dynamic pressure. And in essence, it's kind of like the point at which the pressure is at its maximum, because pressure is is related to the velocity of the rocket and also related to the air density. So there's a point in altitude where, in essence, your density becomes thin enough, and your velocity is high enough such that they both coincide, and then that's like the maximum point at which you're gonna have aerodynamic pressure, pretty much, because any faster you go any higher, your pressure is not going to increase because your air density's dropped off, and below that point obviously you're increasing velocity, so your velocity is going to be lower than at that point at max Q. So that's why there is like a peak at which aerodynamic pressure is at its maximum, which is max Q. So there is some aerospace knowledge for you guys there. Right, now we are facing the moon. We want to try and capture it, so let's set a maneuver here. Whoa. Okay. I think this does a moon intercept? Yeah, okay. We'll do that. We want to do a moon intercept. So, let's lock this onto our target. Which it funnily already is. Just sick. So we have about 35 seconds, to chill, have a chat, and yeah, we'll see how this mission goes. I think it'd be so cool to see rockets launching from UK soil. Actually, I think like there's two companies, Skyroara and Orbex. They're pretty much like the front runners in the UK anyway to launch rockets. But there's actually quite a number of smaller launch companies or people who are working towards figuring out how to improve space launches in the UK, and those two companies are Proto Launch and Small Spark Aerospace Systems. Proto Launch is pretty cool because they are in essence trying to focus on building really efficient small scale engines. Oh no, we've missed the window. I've been chatting too much. Oh well, we hope for the best. Right, let's hope we can catch up. But yeah, in essence, Proto Launch is focusing on developing small-scale rockets, primarily to try and make them more efficient. I think because there's one thing that's really hard with rockets is that it's really difficult to make small-scale systems purely based on the fact that rocketry is so heavily defined on weight to fuel ratio, and the fact that you need more fuel for more weight. It's like a really difficult cycle to, I guess, finesse in essence. And that's why like building smaller rockets like what Rocket Lab have done is actually probably, arguably more difficult than something that SpaceX has done. So that's why, yeah, small launch companies have quite a lot of difficult work ahead of them. Alright, so let's see how this moon encounter will go. It's doing a little tail wiggle. What is going on here? That's a bit dodgy, to be honest. Not a very secure rocket. I should have put RCS thrusters now thinking about it on here. It would have made so much easier to maneuver this, but hey ho. We move. Okay, let's see where we're at. What is this? Okay. Can I add a maneuver here? Oh. Okay. Right. Let's focus this on the target and also 4 times the speed. Oh, no. I overshot the speed. God damn it. Oh well. We'll see what happens. Right, let's see. Oh no, we completely messed this up. Please, let's go to the moon. Yeah, I probably shouldn't have been talking so much and actually concentrated on this, because now kind of messed up. That's the word I was looking for. Right. This is very strange now, because I don't know what's gonna happen. I mean, we're gonna be in orbit, but I don't think we're reaching the moon anytime soon. God damn it. I mean, it's burning fuel. I don't know, will we reach this moon? To be fair, we might actually do it. Let's see. Oh. Okay. We are making progress though, which is a good thing. Holy shit. Could actually do this. Because we do encounter the moon. There we go. Boys and girls, we're gonna actually go to the moon. Okay. Whilst this is burning down. This is actually a madness. Maybe on the first try, with some mistakes, we're still going to end up on the moon. But in the meantime, I guess if you're watching this video, then if you also have questions about, you know, aerospace engineering at university, or you want any advice about it, then do drop a comment under this video. And also do check out my other videos that are way more educational than this one. Because this one is just me chatting random stuff about cool aerospace stuff, and also trying to land on the moon at the same time, which probably is not the best idea, but you know, we move. Okay, let's see our trajectory. So okay. Well, this is interesting, isn't it? Right, so we'll do a bit of warpy warps. Okay. Kind of approaching the moon here. What is going on here? So, here's the moon. Right, so I want to actually intercept the moon. But where is the moon? The moon is over there. How is this ever going to work then? What is going on? Wait, what? Oh, do I have to go around again and again? Alright, let's see how this works. Oh, look at this. I'm gonna actually encounter the moon now. That's kind of mad. Look at this. Some wildness going on here. Ooh, we're gonna encounter the moon. Okay. Where's the moon? There is the moon. Right. Let's figure out how do we best encounter this? Because we're right here. Okay. So retrograde this. We might actually do this, you know. First try landing on the moon. What can I say? Amazing is what I can say. Right, we want to extend these. And I guess also start to decrease our velocity. Because our target is now this. So you can set as target. Okay, as you can see, it's getting quite tense, so see how this goes. Right, I warped it a bit. Now we can retro thrust. Come on, come on, come on, come on. We're still coming in quite hot, actually. Oh no. Oh no, this doesn't look good. This doesn't look good. No, 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 no. Yeah, that wasn't that great, to be honest. That kind of sucked. Bit sad.